In this next part of section 2, we're going to look at something called end behaviors of a graph. Um, End behaviors describes what's happening to a graph as we go further and further out from 0. Um, we've dealt with lines before. If what we have here, let's say this is our x and y axis, and we have this line, then our end behaviors would be as x goes out to infinity, the value of that graph is going to positive infinity, or going to the left as x goes further and further left, as x goes out towards negative infinity. What is the graph doing? How is it behaving? Well, it's going lower and lower. It's going down towards negative infinity. And so that's going to be one of the key things that we want to be able to describe when it comes to polynomials is if we were to graph a polynomial, what is happening to it as it goes further out? Is it going towards positive infinity on both ends? Is it going towards positive infinity on one side and negative on the other? What's happening on the ends? Lots of different interesting things could happen in the middle, but there's some pretty simple ways to describe what's happening out on the ends. So that's what we're looking at in this section here. And there's 4 different cases. So the screen's broken up into 4 different sections so that you can fill out that table that you have there. I'm going to zoom in to make it a little easier to write. But there's 4 different scenarios, and they each depend on the degree of the polynomial and the sign of the leading coefficient. So first, let's consider one where the degree is an odd number and the leading coefficient is positive. So this could be something like f of x equals x cubed plus whatever else. This would be a line with a positive slope would fall into this category. Anything with an odd degree and then a positive leading coefficient. So we're wondering, as x goes really far out, what is happening to that graph? Let's consider as x goes towards positive infinity first. So if we plug in very, very large positive numbers, that first term, that highest power, has so much more weight on the graph than any of the other remaining terms. Because x cubed, when we get to really large numbers, x cubed is going to be so much bigger than x squared or x or that constant term. So those hardly really have any effect on the graph further out. Okay, so as we plug in large positive numbers, cubing those positive numbers is going to give us large positive numbers. So as we go out to the right, this graph is going to positive infinity. So to describe the end behavior to the right, we would say as x goes to positive infinity, f of x approaches positive infinity. Okay. Let's change that so it stands out a little better. Okay. So as x goes towards positive infinity, the value of the function is going towards positive infinity. And what about on the other side? So as x goes towards negative infinity. So if we're plugging in large negative numbers, what happens to x to the third, or I guess any odd power if our degree is odd? Well, an odd number cubed, or sorry, not an odd number, a negative number to an odd power is going to give us a negative number. So as this goes out to the left, as x goes to negative infinity, f of x is going to go to negative infinity. So as we go out towards the left, the value of our function is also decreasing. Now lots of different and interesting things could happen in the middle, and that's what is affected by all those other terms, what happens in the middle. But as far as the end behaviors, that's entirely up to the degree and the leading coefficient. Okay? So let's look at the next case. What if our degree is odd? So our degree is still odd, but we make our leading coefficient negative. So similar as before. So maybe this is now something like f of x equals x to the negative, or sorry, negative x to the fifth, plus a bunch of other stuff. Okay. Well, let's consider x going to the right again first. So as x goes towards a positive infinity, so if we plug in large positive numbers, well, a positive number to the fifth is positive, but then that negative leading coefficient is going to make those positive numbers negative. So this is going down. We're going to get out negative values as we plug in large positive. So as x goes towards positive infinity, f of x is going towards negative infinity. So then looking at the left side of the graph, as x goes towards negative infinity, well, a negative to the fifth power is going to be negative, but then again that negative leading coefficient, so the negative is going to make those positive. So here, if we plug in large negative values, we're going to get out positives. So as x goes towards negative infinity, f of x is going to go towards positive infinity. And again, all sorts of interesting things could happen here in the middle, but what we care about and what we're describing is just the end behaviors. Okay, we're not too concerned about what's going on in the middle. If we were really interested in those things, we would probably just plug them into a graphing calculator, but it's nice to be able to tell the end behaviors just by looking at them at a glance. So that does it for odd. Those are the two cases if we have odd powers, odd degrees. So let's consider then, what if our degree is an even power? So our degree is even, and let's say we have a leading coefficient that is positive. So here's an example that might be familiar. This would be a quadratic that's a positive in the front. And talking about that before, since this term here is positive, we know that this should be opening up, right? And so now we can kind of look at why that is, and the things we'll see will be consistent with what we talked about in chapter 4 in parabolas. So again, let's consider first as x goes towards positive infinity. If we plug in positive numbers, a positive to an even power spits out a positive. So the values we get out are going to be going towards positive infinity. Right? Then as x goes towards negative infinity, when we plug negatives into a term with an even exponent, those are going to give us positive values. So even though we're plugging in large negatives, that's going to spit out large positives, so our end behavior is going to positive infinity. And that matches what we saw with parabolas. That even power is going to make both ends behave the same, whether they're both going up or both going down. An even power, both end behaviors will be the same. And again, these terms here just affect where our vertex might have been, or what other interesting things might happen in the middle. So our last scenario is, what if the degree is even, and the leading coefficient is negative. So that would have been maybe negative x squared plus something else, or this could be negative x to the fourth plus a bunch of other stuff. Okay, but again, either way, let's look at x going towards positive infinity first. So going to the right, if we plug in positive values, x to the fourth, or x to an even, is going to spit out positive values, but then we have that negative coefficient, flipping these and making it go down. So as x goes towards a positive infinity, f of x is going to go towards a negative infinity. So then lastly, as x goes towards negative infinity, as we walk further left, plug in large negative values, a negative to an even power is going to be a positive, but we have that negative coefficient making those values negative. So f of x is going to approach negative infinity. And who knows what might happen in between there. But again, our main concern now is just the end behaviors, what's going on as we go really far away. Okay, so you should have that summed up in your notes there. And let's look at those last two examples now. So we're given the function f of x equals 3x squared plus x minus 1. Describe the end behaviors of the graph as x goes towards infinity and negative infinity. So let's do as x goes towards positive infinity first. So as x goes towards positive infinity, if we plug in large positive values, this again is the only thing that really matters. We can ignore the rest of that. So if we plug in positive values, what do we get out? We're going to get out positive values. So as x goes towards positive infinity, f of x is going towards positive infinity. I guess whether you put the positive there or not doesn't make a huge difference. The one that will matter is if you want negative infinity, you have to include that negative sign. Okay. And what about as x goes towards negative infinity? So if x is going to negative infinity, if we're plugging in large negative values, well, a negative squared is positive, right? And then multiplied by a positive coefficient is still going to be positive. So our end behavior to the left is still a positive infinity. I believe on the test when you do these, you're probably just going to be filling in a blank here. So as x goes towards infinity, what is f of x doing? You're filling in whether it's going to positive or negative infinity. In our final example, we're given negative 4x to the fifth plus. Again, those things don't matter as we determine end behaviors. All we care about is this first part. So as x goes towards infinity, so as we plug in positive numbers, what are we getting out? So x to the fifth, if we plug in positives, is going to come out positive, but that negative exponent, not exponent, sorry, that negative coefficient is going to make those negatives. So if we plug in positives to that term, we get out negatives, so our end behavior is to negative infinity. As x goes towards negative infinity, so if we plug in negative values to that term, a negative to the fifth power is going to be negative, but then that negative coefficient will make those positive. So here, again, our end behavior is going to be going to positive infinity. Okay. So again, end behaviors, we can determine those at a glance, but all the things that are going on in the middle, for right now, we would, if we were really concerned about those, plug them into a graphing calculator or Desmos or something like that to see what's happening in the middle. But being able to determine the end behaviors just at a glance is a useful skill to have going forward.